All right, so like I said, this all relates together. So we did the correlation coefficient, we did the least squares regression line. Now we're going to look at diagnostics on that least squares regression line and how it all affects our data. The first thing we're going to look at is the coefficient of determination. That's my R squared. So R being the correlation coefficient, and so this is squaring that correlation coefficient. This is fancy talk for measures the proportion of total variation in response, in the response variable that is explained by the least squares regression line. What? What are you talking about? This is what I'm talking about. How varied are the data points around that least squares regression line? So what I'm really saying is that coefficient of determination is a measure of how well the least squares regression line describes the relationship between the explanatory and the response. The closer it is to 1, the better the line describes how changes in the explanatory affect the response. So we're just saying, how close is this relationship? How varied are the data points, or how close is that relationship? All right, that's what we want to go for here. Okay, so here are some data values. Set A, B, and C with, I'm going to make these smaller so that you can see all this information. Oh, well, nobody can see that. So there's my data values, and then I'm going to pull it up just a little bit like this. Within those data values, all right, I have let me get my pointer. Oh, I've got it. Set A graphed, set B graphed, and set C graphed in there. All right, so here is data set A, B, and C, and they all have that linear regression line that goes with those different data points. Now, right now, you can look at that and see, right? So your coefficient of determination says how varied are they? So how varied are they from this line? Well, look at that one, 99.99, right? 99.99% of the variability in Y is explained by that least squares regression line. It's on it, right? It is on it. 99.99%, that data is on it. It can be explained. The relationship is there. It's a tight relationship. That's what we're going for, all right? And look at this one. See how close this one is? It's the same kind of thing. It's just the coefficient of determination is another way to look at that correlation coefficient, right? It's squared. So it's based on that correlation coefficient. We're working with this and see how varied the data is. This is a little bit farther away as we go through there. So it's at a 94.7. So not spot on like this first one is, but dang close. Now look at this little fellow over here. It's all over the chart. I have this correlation coefficient that shoots through there, but look at this. 9.4 of the variability, 9.4%, that's all that's explained. Because the data set is so far off. The points are so far off from each other. That's a coefficient of determination. Just one more way to interpret this data. All right, is that coefficient of determination. It is the proportion of total variation in the response that is explained by the least squares regression. That's what I want to know. All right, so let me scoot this over here. We want to use the same data we've been using this whole time, and we're going to determine and interpret the coefficient of determination. Well, guess what? Where do you think you're going to find that coefficient of determination? The exact same place that we have found everything. And I just left it up here. I left it up here from that last thing that we did because it's in the exact same place, right? So if you were to go, I'm going to scoot this down. If you were to go to stat, regression, simple linear, and then we're doing literally the exact same thing. It pulls up this. And there's my R squared. You can also get your handy dandy calculator out and you can square your correlation coefficient, which we figured out previously. So however you want to do that, however, oops, I need an actual pen here, don't I? R squared is going to be 0.8811. 0.8811, because I'm going to go to 4 decimal places again. So we're looking at that, we're rounding it because it's a 4 afterwards. So that is my correlation coefficient. This means, I almost put those 3 dots again. This means 88.11% variability. So how tight and how close is my data? So there is 88% variability. The closer it is to 1, the tighter that data is, the less variability, or what I'm looking at is how one relates to the other, right? That's what we want to say there. Okay, and we're at 88% here. That's pretty good. That is pretty doggone good as you're looking through there. But you can use StatCrunch again in order to pull that information that we have been pulling already right from that graph. All right? Or right from that chart, right from that simple linear part of it.